No, read this one. Usually we came across dn minus dn by dt equal to minus lambda n, no? Here root n. So don't get, it's hypothetical. Or synthetic radioactive substance, you can call it. Synthetic. So don't get carried away by any concept. Don't go for it. It's a pure mathematics. Instead of n, you are having root n. Let it be, no problem. Right, let's go for mathematics. So what is the given? A radioactive substance disintegrates according to disintegration law given by expression dn by dt equal to minus lambda root n, where lambda is the decay constant and n is the number of active or undecayed nuclei at any time t. Initial number of active nuclei are n naught, and the lambda is given how much? 0.414, the value of lambda. The half-life of radioactive sample is asking what is the half-life of it. The time taken by its number, to become half of its initial value. That's what you mean to see. Okay, let's do one thing. dn then substituting limit time taken for the number to become half of initial value. So this is what that t of is asking. Minus 1 by 2, so this will be root 2 root 10 n naught by 2 minus lambda t of. Substitute the values. What is lambda? Lambda is 0.414. I think there should be root 2 minus 1. Root 2 minus 1 will be, so root 2 minus 1, root 2 is what? 1.414 minus 1. So where all lambda is you can write root 2 minus 1 and try to simplify it. This will be 2 n naught by 2 minus n naught lambda t of. Okay, can you hear me?
Yes, sir.
Okay, then yeah, fine. Anybody value t of?
Under root of 2 into n naught.
Under root of 2 n naught. Yeah. Look at that n naught. Half-life depends on the initial number. Hypothetical. Okay, don't crack your head much because we don't have any. Like this hypothetical, I can bring anything. You be careful. The half-life depends on the initial number. What is n naught? N naught is what? So can it happen? Hypothetical. Maybe in future we are able to produce such a radioactive substance. These are called like a synthetic radioactivity. They say synthetic means artificial radioactivity, natural radioactivity and artificial radioactivity. We do have both. Curve representing the number of active nuclei at any time t. Get expression for n as a function of time and check the graph. It will come this one. So for that, what you should do, don't write n naught by 2, write only n. Get expression for n as a function of that and check it, you'll get a curve of this kind. Okay, I think this is something very troublesome for you. Like this, you may get equations of any kind. Be alert. If you see the SC Verma or Singage, no, we don't have such a discussion of artificial radioactivity, but it's a part of syllabus.